So let me start. Let me welcome you to my session. Uh, my name is HOnza Koudelka. I'm from 2 4U Software, and this slide lists some of my passions. The achiever of the impossible means that when someone comes to me and says, "This is not possible," that makes me start thinking and proving him wrong that it's actually possible. And one area where I like to uh, prove that everything is possible is the FileMaker calculation engine. So you will see that's my passion. If you want to learn more about me, there is a link in the bottom. You can easily memorize it. But I will not spend too much time on this slide because I have a lot to share. So today I will have three topics to cover. One is a brief presentation of the results of my team testing FileMaker 2024, comparing it to 2023 in terms of performance. Then I will talk about my favorite topic, calculations performance, and in the end, I have a story to share with you how my team optimized a web-based portal that's connected to a FileMaker backend. It's actually a portal that we use for all our clients. So it was very important for us to optimize it as much as possible. So let me start with FileMaker 23 versus 2024, 3 versus 2024. Or if you look at the Get FileMaker application version, that's 20 versus 21. So depending on whether you are in marketing or engineering, different version numbers, but you are already used to it, I guess. So this is the environment that we used for the testing to make sure that both versions are tested on the exact same environment. We intentionally didn't use the latest, fastest hardware, but something a little bit older in order to make it match what typical clients are using, because not everyone is using the newest hardware to run FileMaker on. And if they do, after a few years, it will not be the newest anymore. So it's just usable hardware, and just making it consistent across all the tests helps us also compare it with past results that we achieved, we collected in the previous years as well. So we started with our bench test tool that you can download free of charge on our website and run on your own. It has a script with standard test, or we call it standard test. It consists of 111 different test scripts, and with this standard test, we found the performance of both versions, the last year's one and this year's one, almost the same. What is interesting is that on a slow network, where we simulated a wide area network, we consistently got slightly better results with the newer version. So that's a good sign that FileMaker or Claris is actually putting some efforts into making FileMaker work better on a wide area network. But it was not any like magic. It was slightly faster. We were also looking at one thing, that's the slow relationship graph, because one thing that was actually mentioned in the release notes and pre-announced even before Claris released the new version was that they improved the way how FileMaker caches the relationship graph data, and so we thought it might be worth retesting how it deals with especially huge relationship graph, which we know to be a big bottleneck in many solutions, especially when you have thousands of table occurrences in a single table occurrence group. Just opening the solution can be very, very slow. So as part of the bench test, we also have a series of tests specifically targeted as this. We are using a solution provided several years ago by Vincent Lunier, where he experienced very slow record creation even though he was creating those records in a completely isolated table occurrence. So that's what we use for our standard testing, and we didn't notice any significant difference between those two versions. So we went to try one more thing, and we tried it in our own real solutions. We picked two solutions that we intentionally even implemented the script queue to run server-side scripts instead of using perform script on server, because on those two solutions, just starting a script on server takes several seconds, only because of the big relationship graph and because every new script starts a new session. So we were curious how the new version deals with that. So this is the script that we used, where basically if it runs on a client, it calls itself as a script on a server, and it collects the timestamp when it triggers the script on the server, and the timestamp when the script on the server actually starts running. So we were literally measuring just the delay from asking the server to start the script to the point where the server finally started the script. And as I mentioned, we tried with two solutions. This is our internal CRM or ERP, and the collector is our project management tool that we use for our software development projects. And we did get slightly better results with the version 21, but nothing significant. So the outcome of this test is that probably what the caching of the relationship helped with was perhaps loading the relationship data, but that's not the bottleneck. The bottleneck is processing the relationship data. So you may know from some older DEFCON session from Clay Meckle under the hood how FileMaker opens a file that as part of the process it loads the relationship data from the database, and then it processes it and builds something they call, I believe, master list of table or of all relationships or something like that. And this probably seems to be happening every time for a new session, even if the relationship data is cached. So this process, which seems to be bottleneck of starting a new session, seems to be happening even after the data for the relationships is loaded from a cache. And that's pretty all. Every other test that we ran on 21 versus 20 showed exactly the same results on both versions. So no significant change, which is kind of also good news that it didn't become slower. But no significant change towards better performance, especially on a single client testing. What is difficult to test, and we didn't test as part of this as part of this experience, is that Claris is putting a lot of effort into making it better handle a lot of concurrent users. But that's also very difficult to test. It's costly to test. So if you do have clients with like hundreds of concurrent users and need to test it, we can help you with that. But just running those tests takes a lot of effort. So we don't do it just without having a specific target or specific need for it. So that's about comparing FileMaker 21 and 20 from the perspective of performance. And now let's talk a little bit about calculations. And I want to tell you why every millisecond can matter. Some time ago, I think it was 2 or 3 years ago, I was working on some complex calculation, and I turned to the community with asking a question how to optimize this loop, because it was taking me like 200 milliseconds and I wanted to cut it to less than 100 milliseconds or something like that. And one developer responded, I don't recall who that was, is, well, if it takes 200 milliseconds, I don't care. Would you agree with him? Well, the point is it depends. There are situations where 200 milliseconds is really not too long, but there are situations when a single millisecond is way too long. So to prove my point and show when it actually matters, I use this starter solution made by Alexis Allen. This is primarily a starter solution to use a nice modern looking theme for user interface, but it's also a very simple invoicing solution that you can just take and start using. And I reminded myself of how we started our company when we created the first information system for ourselves. One of the first things that we needed to do was invoicing. And so I recall what kinds of requests I was getting from my colleagues. So obviously, when you issue an invoice, there are cases where someone pays late, right? Or someone pays just half of the invoice or forgets to pay the VAT. So it's not sufficient to just have a field saying it's paid or unpaid. You may need to collect information how much was paid and when it was paid, so you can differentiate between customers who are paying early, who are paying late, who are still owing you money even though the invoices are after you. So you may have to need a way how to say, okay, this invoice is early paid, this is on time, this is late, this is overdue, and especially if you're starting, if you're you junior developer with less, not enough experience, or if you just don't have enough time, manager comes to you, I need this, but I don't want you to spend more than 5 minutes with this, right? So you come up with a quick solution. So I created this simple calculation, seemingly innocent, and I even measured how long it takes to evaluate, and it was really taking very small time. I have it on a later slide. I think it was somewhere around 1 millisecond or maybe less. So this was the innocent calculation, and in order to measure how much time it takes and how many times it gets evaluated by FileMaker, because that's how 1 millisecond starts making matter, when the calculation doesn't evaluate only once but many times, right? And many times 1 millisecond is many milliseconds. So I added this this calculation in the end to measure the time and counts, and started collecting some statistics. So I put that field on the layout, so I could see what's the status of the calculation. But as you can imagine, if you have a list of invoices and there is a text field showing, well, this is overdue, this is due, this is late, it's not much helpful because it's difficult to recognize those invoices that need your attention. So we got a great thing in FileMaker, and it's called conditional formatting. So it's easy to say, well, I want the late invoices or the overdue invoices to be red and the early ones to be green and so on. So you add a few conditional formatting rules, and it's very easy to add, right? So it only takes you a minute or two to add this to the solution, and you end up with a very nice layout showing invoices in color, and it serves the purpose. Now let's say we have a lot of overdue invoices, and the summer is starting, and some student comes and they want apply for internship. So you get the idea. Let's hire an intern and let him call all the customers who are overdue and ask them to pay. But you don't want the intern to have access to all your invoices. So you want to set up some privileges so that the intern only sees the invoices which are overdue or due, because the other ones are none of their interns' business. Okay, so you can set up a privilege set with a record level privilege and use the calculation that you already have there to decide whether the intern should have access to it. Okay, so now let's talk about what impact this has on the performance of your solution. And sorry, one last thing. You get a request from the manager. Okay, so let's focus on the most important invoices first. So let's sort them by the status. So this not so innocent script step comes into play, and when you switch to the layout with the invoice list, you sort them in the right order. Okay, so to measure the impact, I added a very simple thing in the script that switches layouts, because a few years ago I discovered that in order to measure how long it takes to render a layout, the most accurate way is to trigger on-timer script trigger, because that doesn't start until the layout rendering is finished. So I use this on-timer trigger, and in the script that starts with the trigger, I collect the ending time of that rendering and display a dialog to show how long it took to switch between those two layouts. So this is the dialog that shows up after starting the script. And this is the layout with the invoices, with the conditional formatting and sorted by, I think this is not yet sorted, but anyway, it shows the conditional formatting. And now try to guess what we found out. So yeah, the single evaluation of that calculation was actually taking between 100 and 200 microseconds. So it was 1/10 of a second, of a millisecond, sorry. So you would say that's negligible, right? That doesn't matter. And I don't want you to guess the times, but try to guess how many times the calculation needs to be evaluated. When I just have the field on the layout and display 10 records. Any guesses? 10 times? Any other guess? Okay, well, the first one is easy. The 10 is correct. However, back in FileMaker, I believe 17, that was probably the last one, this was not true. In that version, it would be 40. Do you know why? Because there, FileMaker, as it has the different styles, for every object, it has 4 different styles: normal, on hover, active, and pressed. And I believe that was the reason why every calculation was evaluated 4 times. Sorry, maybe not here, but maybe in the conditional formatting. Sorry, I was wrong. In the conditional formatting, it will be 4 times more, because it was actually pre-calculating all the styles, so that when you, let's say, move the mouse over an object, it doesn't have to calculate it at that time. So it was pre-calculated. Now it only happens once for each object, but still, with the conditional formatting, how many times? 20? Any other guess? So we have 310 times. And the reason is, as you could see, we have 6 fields on the layout, which were conditional formatted. And I had 5 conditional formatting rules. And in the conditional formatting, what happens is that every rule gets evaluated. Not just the first one, even because you can have additive styles. You can have one rule adding a bold, another adding a color, another adding a background color. So every single conditional formatting rule gets evaluated. And if you reference a custom function or unstored calculation in that conditional formatting rule, it gets re-evaluated for every rule. So with 6 fields and 5 rules, it's 300 times evaluation. Now, when I added that privilege for the intern and use the different privilege to log into the database, guess how many times this calculation was evaluated? And as a reminder, there is 5,000 invoices in the database, and I'm showing it in a list view with 10 records. So all of it? Another guess? Okay, so it's 730. So it was not evaluating for all records, but it was evaluated for in order to find out which records to show. So it was processing a larger number of records than just those that were visible. And when I sorted all the records as a full access, so back to full access, when I sorted all the records with a script, how many times do you think it was evaluated? It's easy. There are 5,000 invoices, so it needs to be more than 5,000, and it is. But more important is the time here. On a local network, it was already taking 14 seconds, and on a internet, it was 50 seconds just to switch between layouts. And when I added that limited privilege set for the intern, it was even more than 6,000 and more than 50 seconds over the internet. Obviously, this is not a practical example, because if you add a sort to your script and you discover that it takes 1 minute to switch between layouts, you revert back and find a different way how to solve it, and you will not make this kind of mistake. But consider that I made just 4 changes to the database. 4 simple changes. How many simple changes in response to your customer or managers do you do every day? If you total it over a year, it's thousands of small, innocent changes, but they add up. Now raise your hands if you try to compare speed of your solution today to how fast it was a year ago. And anyone doing it? If you do it, it's good, because it's like boiling a frog. Actually, that story is fake. The frog will jump out, but our customer will not. So the FileMaker solution, if you keep working on it, will gradually slow down, only because it does not make sense to optimize every single bit you make there. It doesn't make sense. It would be 10 times more expensive to do all the development. But it makes sense to measure it once a year or once a quarter, whatever is meaningful for you, and find out where you added a new bottleneck and take care of it. Not everything, but the bottleneck, because you do gradually slow down your solution only by working on it. And so does Claris with FileMaker. By adding code, you slow it down because it has more to do. It's natural and it's not bad. What would be bad is to ignore it. And with the calculations in FileMaker, these are all the places I could think of, I could recall where you can use calculations in FileMaker. And as you can see here, with every new version, or almost every new version, we are getting more. So we are using calculations more and more. Back in FileMaker Pro version 1, we could only create calculated fields, and that was it. Nothing else. Now all these places let us use calculations, and we use them heavily. Who uses height object when calculations? Raise your hands. Almost everyone. Who uses, let's say, conditional formatting? And how about portal filters? So you get it. And how many of you already use layout calculations? Not so many, but some of you are. So all these places can use calculations, and all these places can trigger calculations to be evaluated. And we very often don't know, as you could guess from your guesses on the previous slide, we often don't know how many times they are triggered until we try to measure it or until we see the final impact. But the impact of a single calculation is typically negligible, like 1 second. But you have hundreds of them. So it's important that calculations take time and we use them more and more. So that's what led me to suggest back 3 years ago to Claris to make the calculation engine significantly faster. I was wondering how much it is possible to make it faster, how much space there is for optimizing the calculation engine. So I wrote this reference calculation for benchmarking. This part is for mathematics. I used the functions that I believe are the most widely used in business solutions, such as summaries and averages. And wrote this loop and calculated how many times the loop will be able to be will be evaluated in, I believe, 10 seconds. Then I wrote this one for dealing with text values. Again, something that we very often use, such as getting the first or last characters or middle values, something like that, and building a list of multiple values, changing the case, and again calculated how many times this evaluates in 10 seconds. And I compared FileMaker 20, PHP, Python, and JavaScript. And this was the result. And this time, wider bar means faster, so that's number of cycles per second. You see that the FileMaker 20 does have some bars there, but they are hardly to see. And with JavaScript, I think it's like 1,000 or 10,000 faster for mathematical operations. What was quite surprising, however, was that for math, Python was about the same fast as FileMaker. So FileMaker is not the only environment where there is a space for optimization, but the JavaScript results show us there is a space, and even if we use small portion of that space, we can still get the calculation engine at least 10 or 20 times faster. So that's what I'm trying to challenge Claris, but not only challenge me, Christian Schmitz, and others have even offered Claris help with this. Okay, you have a question? We could talk about it for half an hour or more. So part of it I know, part of it I guess, but the point is there is a space, and we don't need to reach this target. That would be too challenging. We can still make it significantly faster, and that's what I'm trying to make happen. And you can help me to tell Claris it's important. So if you have not voted yet for my idea, you can do now. And to convince you more, you can see your votes live. So let's try to push the bar a little bit to the right. I'll give you a few moments, and let's see if we can get to actually We are a little bit before the half of the target. Just to explain, the target is actually the number of votes or points that the number one idea in the Claris community has right now, plus one vote. So if we reach this target, my idea will be the number one top voted idea in the Claris community. Right now it's, I think, somewhere around the 8th place. And yes, you have to log in with your Claris ID in order to be able to vote. And you have to scroll, the vote button is below the discussion. So you have to scroll to the end of the page. And we got one vote already, so it's moving. Great. Another one, great. Thank you. So let's see if we can get two more, and that will get us past the half of the target. Now we are exactly in the middle. Yes, you have a question? Okay, just to repeat, you're asking if I'm measuring JSON functions. From time to time I am, especially if I'm using them in my custom functions, then I do this, not every time, and they are improving. But it's not so significant yet. There are some suggestions that have not been applied yet. One of them, which at least Clay Michael confirmed that they are considering, but it's not so easy to make the decision, is because JSON basically is a text value, but in order to work with it, you have to parse it to an object inside the code, and then you work with it. And one suggestion was storing a hash of the text value of the JSON, and if it doesn't change, just reuse that object. So keep the object in the memory and reuse it in the next in the next function. It's one of the suggestions, not been. I'm not sure if it will get to it, but it's one of the ways how to make it faster. On the other side, there are other functions which you have to still use even with JSON, and those would benefit from optimization even more, because then also working with JSON would be faster. One interesting discovery from Claris Engage, someone there asked a question for me, when is Claris going to make the calculation engine faster? I liked one thing that Clay mentioned when trying to work around the answer. He said that as Claris added the AI functions, they themselves started needing the calculation engine to be faster in some situations. So there may be even arguments inside Claris for making the calculation engine faster. But your support is going to help as well, hopefully. Yeah, good. Thanks for the reminder. We have a physical representation of this progress indicator at our booth here on the roll-up. So just go there, take the pen, and fill in one slot for your vote, so that we have it indicated there as well. Okay, so that's so far for voting. Thanks a lot for your support. We literally got more than just past the half today. And that's about the calculation engine. And now let's get to the story of our web-based client portal. So this is a portal that we built for our customers to have a single place where they submit requests, and they can see the progress and so on. And we the portal consists of two parts. In the top, we deal with support. In the bottom part, we deal with scheduled development. So it's kind of backlog of things that the customers want to have developed. They can reorder the requests in the order of importance. They can see our estimates, and based on the estimates, the portal automatically, and based on the capacity that we have allocated for the customer, the portal automatically suggests in which month each request is likely to be finished. Originally, we applied the portal for every service level agreement customer, and because they loved it, we decided, okay, let's go further and let's use it for every customer, even though it's, for instance, a one-time job. And everyone learns from mistakes, so we let me admit that we made one mistake as well in this regard, and that's we knew that we are getting more clients, and every client is putting more requests into the portal. But what we forgot to consider is that with those two counts growing at the same time, the total number of records that the portal needs to process is actually growing exponentially. So after a few months of using the portal and putting data into it, we got into a situation that customers started calling us instead of putting requests into the portal because it was faster. The portal started being slow. Just reordering the backlog, changing order of 2 items in the backlog was taking 22 seconds in some cases. So you can imagine that if you have 20 items in the backlog and you just want to shuffle them around, you cannot wait 20 seconds for every single change, right? It would be a nightmare. So we decided this needs to be optimized, but it would not be sufficient to make it just a little bit faster or even twice as fast. So we just forgot about thinking about the current measures, current values, and we set a target time for every operation, thinking about, okay, when I'm in the shoes of a customer, what will be acceptable time for this kind of operation? And this is what we set. And specifically for some operations that needs to be very quick, we use the iBlink time, which is something around 400 milliseconds typically, as a measure, because if something is faster than an iBlink, then you, as a user, are going to consider it fast enough, because you don't worry. You just blink your eyes and it's done. So it's fast. So especially for changing order in the backlog, we decided we want to make that faster than an iBlink. So we started analyzing what's taking so long, and the portal was connected to our FileMaker backend using Data API. And when we analyzed it, we discovered that we had 5 Data API calls in the beginning of any request. Then specifically in the case of reordering items in the backlog, there was a almost 16 seconds consumed by running a script that recalculated the order of the items and recalculated which month should each item be put into in the schedule. So you could see that the order update itself was just about 120 milliseconds, but almost 60 seconds was for the schedule update. The problem we saw when we looked at the numbers and at the targets that we set is that it's not enough to optimize one bottleneck, because even single number here, almost every single number here was more than that target that we wanted to achieve. So it was really a challenge. So we started thinking, what are the possible ways how to make it so much faster? The first idea that came to us, our minds, was let's use a external SQL database. So it's a web-based application, so we will use something like MySQL, and we will just synchronize the data between FileMaker and the MySQL, because MySQL is known to be quite fast for such operations. Now, the problem with MySQL would be that it would be a lot of effort to organize to arrange the synchronization of the data, and we would literally have to keep the data in two places. So any future update would be a lot more work than we were used to. So we considered other things. Someone suggested let's replace data API with OData. So we tried that, but we did a very simple test. We just replaced data API with OData in the code that we already had. And we discovered that it was even worse. So we thought, okay, that's a dead end, not going that direction. Luckily, another colleague who was not the one involved in this project, independently on this thing, tested OData for a different project, and he had opposite results. He discovered that OData for him was much faster. But because we have a team and we talk to each other, he mentioned this in a meeting and said, well, okay, we may have been doing something wrong with the test, so let's give it another try. And we discovered that what was wrong with the first result with OData was that we were actually pulling all fields from the table that we were pulling data from. And when we explicitly specified just a few fields that we needed from the table, we started getting the results much faster. So that was a good sign. And we did some more tests and ended up writing our own simple PHP wrapper around the OData interface to make it easy to migrate the old code to the from data API to OData. And later on, we did some more tests to have more accurate results that we can share. So this was the initial test where with data API we were actually pulling only some fields, but all necessary fields. You know that with data API you rely on a layout, so it gives you all the fields that are on the layout that you use for data API call. And we had like 5 different requests. For each of those requests we needed a different set of fields, but we didn't want to put so much effort into creating 5 different layouts for it, so we had just one PHP layout with all the fields that were used at least in one of the requests. That could be better if we had 5 different layouts, because we could optimize at least some of the calls. Anyway, the second result that you see is the wrong one, where we pulled all the fields. When we limited the fields with the OData, we got to 81 microseconds. That was already promising because we got under that target time that we were looking for. And we could limit it even more by also applying some filters, because originally we were pulling all the backlog from all the requests from the server, even those that were already closed. So for instance, just by limiting, just by requesting only the still open requests, unless we want to look at in the history, we could limit the time further. And to get some more comparison, we try to do a more exact test with exact same requests through data API and OData. So we try to pull exactly 40 fields from the table on 2 different record sets. And even with this, the OData was faster, even though it was not so dramatic, because now we knew that it's so important to avoid pulling a field that we don't need. So we also considered, okay, if data API is faster with this, we will go and create those additional layouts. But OData was actually faster for us, so we finally decided to go with the OData. The next thing was updating the data, because as you may imagine, if we reorder the backlog, we also need to push the new order back to the FileMaker server. So we were looking for different ways how to update the set of records, and we tried different approaches. The problem with both OData and Data API, it's not that easy to update multiple records in a single call. Updating one record is pretty easy. Updating multiple records is not so easy. So in OData we tried a batch request, which basically sends multiple requests in a single request, and it was not working that well for us. So the approach that actually turned out to be much better was running a script and sending the values to it as a parameter. So FileMaker script in our case, but I'm explicit emphasizing in our case, was faster. But the actual speed depends on how much data you are actually pushing there and what changes you are making. Because in our case, it was just 2 numbers per record. So it was not too much. We didn't try all other ideas, basically because the speed that we achieved was sufficient for us, but we know there is still space for improvement, and we even decided to go with the OData, even though in this case running script through Data API is faster or seems faster than running a script through OData. And you may know that running a script through any of those two interfaces is actually FileMaker's extension, because proper RESTful API does not allow running an action like running a script. So it's FileMaker's extension that it allows you to run a script. But in this case, with up to 50 records updated with just one number, it's faster to run a script than try to update the data directly. But what we didn't try, and what might be also a fast method, is portal with a Data API. So with a Data API, you can have a portal on that layout, and if you send data for that portal, that's actually one transaction that updates multiple records. Does anyone have any other idea how to update multiple records through some API? Because there may be some more, but we didn't explore them yet. Well, even the batch request should be a single transaction, so I think that's what we did with the script. Okay, that's worth trying. I would guess that would be a fast method for a larger number of records. But there is an overhead with writing the file and reading it, so again, it may depend on the case. Anyway, a quick summary of what we discovered. There are cases where it's better to use Data API, and there are cases where it's better to use OData. And your situation may vary a little bit, but what's important in both cases and what's good is that you can and you should limit the number of fields that you are dealing with. Although on Data API, you need to do it through a layout. So for every different field set, you need to create a new layout. And there's the layout dependency here. So it's actually benefit of OData that you don't have to create any layouts. Every single request can have its own set of fields that you're sending or reading. Data API is much easier to work with, at least for a beginner. So learning OData is a little bit more complex. It's also easier to deal with error messages, because in Data API you get not only error number but also the error message, so you can easily display it and know what's going on when an error appears. With OData you just get a HTTP error code and you have to map it to actual error message. On the other side, it's much easier to authenticate with OData because you just send the authentication with the request. With Data API, there is a two-step process. In the first step, you have to get a token, and in the second step, you use the token, and the token has a limited validity, so it expires after some time. I talked about the layout dependency. There is a slight overhead extra in the data API because it needs to deal with the layouts. So the OData doesn't deal with layouts, doesn't deal with many stuff that data API deals with. So for a single request, there is slightly lower overhead of OData. And there is going to be even lower overhead in the future because as we learned recently, current implementation of OData goes through the same path, same channel to the FileMaker server as the XML interface, but in the future it's going to be connected directly to the database engine. So I expect, hopefully in the next major release next year, we are going to see a significant speed increase with OData. So just a brief recap of our story, our path. We tried OData for multiple records, and we used FileMaker script to update those records. Through OData, it's good to omit unnecessary records, just like always, even though you deal with a small set of records initially, because when we started with the portal, just pulling all the records from the database was taking so little time that we didn't think about this. But as the number of records in the database started growing exponentially, keeping the number of records that we are pulling from the database at a reasonable number was quite important. We also cached some data, so as you could remember, we had 5 calls to the data API for each request, but some of them were not so necessary because we were, for instance, pulling list of users to check whether the user still has access to the data, so that we could just kick him off if we disable the account. Some things like project details were not necessary to pull every time from the FileMaker. So if it's something that changes only less often, like once a month or even less, that it's worth caching on the web server and maybe only checking the modification timestamp and only pulling the data if there is a change. We also moved the most complex part, which was taking the 16 seconds in the FileMaker. We moved it completely to the web because we did not use that estimation which month each request is going to be finished for internal planning. It was just showing to the customer when it's likely to be finished. So it was only used for the web. And calculating it in PHP took just fraction of a second. And so we just pulled the source data from FileMaker, calculated the estimates in the web interface or on a web server, and got completely rid of that 16-second script. And for everything else that we needed to pull from FileMaker, instead of having multiple HTTP calls, we combine that into a single call. So just single HTTP call through Ajax to minimize the number of packets or requests going between the server and the client and the server. And here we recorded the difference between the optimized and the old version of the portal. I have 2 timers here. This is the overall time, and the top one is just user doing something. So this one is independent on the performance of the portal. This is the total time. And what you will see is a typical work of the user. So here, the user logs into the portal. You can see that the new one is already putting in a new request. After putting in the new request, we go to the request and edit it because we discovered there is something to be added. And then we reorder the backlog by putting the new request to the top. And with the new portal, we are already finished. And out of the 24 seconds, 20 seconds was the user time, so only 4.5 seconds was actually processing the requests, all the requests. While in the old version, we are still just editing the new requests. We have not got back to actually reordering the backlog. So after 1 minute and a little bit more, you'll be finally able to actually take the new request and put it in the front of the backlog. It's still saving. Okay, it's maybe 1.5 minutes. So now let's take the request and pull it to the front. And this was the main reason why we decided to optimize the portal. So now it's time to go to a kitchen, make a coffee. And while drinking the coffee, I will completely forgot what I wanted to do, right? Okay, so now after almost 2 minutes, we are finally done. So instead of almost 2 minutes, we got to 24 seconds, but that includes the user time. So actually, from 1.5 minutes to 4 seconds was the actual optimization. And here you can see it in the charts for the individual actions. So the blue are the targets that we set, and the green are the actual results. And here are the worst ones, and changing order in the backlog, we got under 100 milliseconds. The only one where we got a little bit worse, it was on the previous slide, but it was still acceptable. Otherwise, everything we surpassed the targets that we set. So it was very successful optimization. And one thing to mention about the changing order in the backlog, one more thing that helped us to achieve this result is that we made it asynchronous. Because when we change the order in the backlog, we don't need to wait for the order to be updated on the server, because we already have the tasks in the right order in the browser. So in order to change to reorder other tasks, we can do this immediately, and we don't mind that it will take 1 second, or in our case 200 milliseconds, to actually propagate that to the server. And having it propagated in less than a second is still fast enough, because we will not work with that update until next day, for instance. So this is the final result, and let me recap some lessons that we learned on the path. So it's good to cache data that's don't changing very often. So, and this is quite important condition. Whenever you consider caching or not caching data, the most important question is, how often does the data update? Does it change every minute? Does it change every day? Does it change once a month? And that will help you to decide whether it's worth caching or not. And compare that to how many times the data needs to be displayed to the user or evaluated. So if it's displayed to the user 100 times per day and only changes once a day, it's worth caching. But if it changes between all different requests, then you need to read it on the fly from the database. Another thing is, we can easily underestimate a new technology if we don't know enough about it. So doing just a simple test may not be enough to understand what it can bring us. So a new technology is coming to FileMaker with every release. So don't underestimate the new features that you get. You can think they are not useful for you now, and you can find them extremely useful tomorrow. So don't underestimate them, and don't rely only on a single test, because you may be just testing it in incorrect conditions. Now, one thing that we learned about OData is that it's sensitive to text and value formats. So we had to deal with some special characters in our values, especially in the request descriptions. It's something to deal with. But the most important lesson is that making mistakes is actually a good thing. And why is it a good thing? Let me take a look at it from slightly scientific angle of view. Because when you make in any development or discovery process, you will make mistakes. Forget about that they taught us in school that mistakes are bad. It's part of the process, but what happens when you make a mistake and you realize you made a mistake? It produces an emotion. You may be angry, you may be disappointed, whatever. It's usually a negative emotion, but it's still an emotion. And what I learned from a woman who is expert in working with memory and memorizing things, she said, well, how the human brain works is that emotions actually tell the brain this is worth remembering. If you have no emotions, you don't remember anything. But if you get hurt, that's something that your brain decides to remember, because it wants to use it to protect you against being hurt again. On the other side, if you have a positive emotions, that's something you want to repeat. So your brain wants to remember the situation that produced that positive emotion, because you want to produce it again and again. So the stronger the emotion is, the more likely you are going to remember any details about it. So if you make a mistake, and if you are emotional about that mistake, you will remember it, and that increases the probability that you will be able to avoid it next time. And that's all for today, and I'm ready for any questions. So, do you have any? Semantic search. We started working with it. We are still exploring different models to work with. So yes, we started testing it, but we don't have any significant results to share. Whether semantic search is depending on field index. Actually, semantic search depends on different values being searched. So it's based on vector data. You create embeddings for all your data, and semantic search compares those embeddings by calculating the cosine similarity, and actually ordering the records based on how close they are to the request. In order for this to be done, what I learned from Wei Chu's session from Claris Engage is that FileMaker actually builds a special kind of index for the semantic search, but Claris still has not revealed any details about how the index is built, where it's stored, and how it's managed. So it's not the field index. The traditional FileMaker field index is involved in a different way. You can store the vector, the embeddings, either in a container as a binary data, or you can store it in a text field. If you store it in a text field and you have index enabled for that text field, you can get a huge database, because every vector, every embedding is unique. So you are and it has, I believe, 4096 values in the vector. So it's a huge amount of data that you are storing, and if you build index for that huge data, the index is going to be even bigger. So it's recommended that you store the embeddings into container fields, not in text fields. Or if you store it in text fields, you uh, manually disable the index to make sure that this doesn't happen. But the index itself is not used for the semantic search itself. Semantic search is applied on the current found set as a constraint by going through all the records and comparing the embeddings, embedding vectors with the vector of the request of the query. And it is said to be using a vector index, which is built the first time you actually perform the semantic search. Any other questions, Andres? Mm-hmm. Whether we consider Color Studio for what? For calculation optimization? Well, Clara Studio has its own calculation engine. It's not the same calculation engine as FileMaker uses. It's not even the same syntax, even though it's relatively close. It's using even different names of some functions. So what FileMaker needs is to keep the existing calculations functional. So they cannot afford breaking existing solutions. So replacing the FileMaker calculation engine with the Clara Studio calculation engine is not going to work. What might be interesting option is adding the Studio calculation engine as an option to use, but that would only impact new solutions where you actually use it. So what my initiative is trying to achieve is making the calculations faster for existing solutions for everyone. So even though adding support for either Studio calculation engine or JavaScript or anything like that into the FileMaker as an extra option is definitely a good thing, but does not solve the existing solutions. Any more questions? So the question is whether there is a benefit of offloading calculations to JavaScript through WebViewer. Yes, and that's also often used today by people who deal with complex calculations and need to speed them up. Although it has some limitations. One is that it only can be done on a client because you cannot use WebViewer on a server. The other thing is it's a little bit more complex to implement. You have to display, you have to have the web viewer actually visible on the current layout, even if you make it 10 by 10 pixels, because I believe that's the smallest web viewer you can create. You cannot make it 1 pixel wide. The other thing is when you actually go to that layer with the web viewer, you have to wait a little before it actually starts accepting the JavaScript calls. So if you already have the web viewer active on a layout, you can trigger JavaScript in it immediately. But if you switch to a different layout and there is a web viewer, it takes some time, maybe 100 milliseconds, before the web viewer is actually ready to run JavaScript code. And then you need a way how to push the results back to FileMaker. So the way to do it is you go to WebView, show a web viewer, load a very simple HTML page in the web viewer, then use perform JavaScript from a script, and then in the JavaScript you perform another script in FileMaker to which you post the result as a parameter. So it's really not that easy to do. If you have a calculation that takes 1 second, it's probably not worth doing. But if you have a calculation that takes minutes, you can cut it to seconds using this approach, definitely. As an additional option, but that requires a plugin like MBS plugin, you can use a server side or like a faceless JavaScript, and that's another option. But then you need a plugin for it. So not a native way to do it. Go ahead. Mm-hmm. Okay. Yeah. Just to repeat for recording, you said you had a case where you had a JSON with a lot of coordinates. Processing it in a while loop in a calculation took you 20 seconds. So you use JavaScript in WebViewer to have it in fraction of a second. Addition to that, there may be also ways to optimize it within the calculation, because one of the things that I learned perhaps 2 years ago was that if you have a list of values that you want to process in a loop, uh, the worst way to do it is using the get value with a incrementing counter. The fastest way that I discovered was just taking the first value of the list and removing it with the replace function, and then going to the next one and again removing it from the list. For a large number of values, it was even better to combine this method with chunking. So I split that. If it was in JSON, I would turn it to a just return delimited list first, and then if it's more than, I believe, 500 values, it makes sense to split it to smaller chunks using the middle values function. Uh, the length of the chunks depends on the use case, but in most cases the optimal chunk size is between 500 and 2000 values, and then processing those chunks using that replace function. So that turned to be the fastest way how to do it in the calculation engine. But yes, specifically JSON is a native format for JavaScript. It comes from JavaScript. The JSON abbreviation means JavaScript Object Notation. So it's native for JavaScript to work with JSON. Any more questions? Okay, so thanks for your attention, and if you come up with some other questions later, just find me around, and I will be